Hi, I'm Chuck, KK6USY. Welcome to Ham Radio Ventures. Today we're going to talk about wire antennas. Why wire antennas? Because wire antennas are the most economical antennas that you can do, and they're easy to build. Now you'll hear a lot of hams and especially YouTube hams talking about all antennas are a compromise. Well, that's true, but the way you make it can make it less of a compromise, if that makes sense. Like using quality materials and not cheaping out on the parts like the wire and stuff like that that make the most of the antenna. So let's take a look at the wire antennas that I have listed here. Now you'll notice that I listed, I think, 8 plus 2, 10. I have 12 antennas total. And that's because some of the antennas actually are the same but different, if that makes sense. They'll make more sense to you guys once we talk about it. First antenna we're going to talk about is the dipole. Now the dipole is the antenna that most antennas are put against just to get a reference point. So dipole is the ref. So the first one is the dipole. The description is: a dipole is a fundamental and simple antenna consisting of two conductive elements, usually wires of equal length. The total length of a half-wave dipole is approximately 1/2 the wavelength of the desired frequency. That's why it's called a half-wave dipole. Now each element is about a quarter wavelength in length, and I say about because you basically have to adjust them. It's typically fed in the center, and then the two wires go out. Sometimes you can put a one-to-one at the beginning here. What I prefer to do, especially for portable work where your masts are not as heavy duty, is use a choke in line and down just a little ways from the antenna, so it doesn't bend the mast over as bad, because a lot of times you're using lightweight mast, right? There are various different ways of putting these up, and the one we're talking about right now is a dipole is a flat top, and we'll get into other ones later. Now you want to try and get your dipole up at least half of a wavelength. Now on the higher bands, that's not too hard. The lower bands, 40 and lower, it gets kind of hard to get it a half wave above. As high as you can get it, the better it'll work. Now, when it is flat, it will, if you do get it a half wave or higher, it does have directionality. Now, the ends are out here, and the directionality is this way on the sides. Dipoles offer good performance and efficiency, especially when installed at reasonable height. A height of at least a half wave length is a good guideline, but most users achieve good results at lower installations. So you don't have to get it a half, but the higher you get it, the better. It's a resonant antenna that means it performs best at a design frequency, the frequency which you design it for. Like if you made a 20-meter dipole, it's good for 20. Performance can be affected by local noise, which can be mitigated with a balun or other matching device. Dipoles are known to outperform many other antennas in certain situations, even when they are simple wire versions. The do-it-yourself factor is very high because the dipole is one of the simplest antennas to build. Basic materials are wires, insulators, and a way to connect the feed line like a balun. An ideal project for beginners such as new hams operators who can learn basic principles of building one. And sometimes buying kits is the way to go, and we'll talk a little bit more about that later. So when you do build one of these, you always want to make it, say if it says 17 feet is perfect, make it 17 and a half or 18 feet. And start there, and then start bending the ends over. What I usually do is I bend it over, I get it closer to where I want it, and then I start trimming that, and then see where that's at, because that will change it also just by trimming it. And then I bend more, and then trim more, and eventually get it to where I want it. I usually have the ends set up to where I can make them longer or shorter if I want to. Okay, so that's a simple way. All right, let's get on to number 2. Okay, it's kind of the same thing. Number 2 is an inverted dipole, which means it sets like this, okay? The center's here and the sides come down. You want to be more than, you don't want it to be like this. You want to be more than at least a 90 degrees to 120 degrees. And that will get your best results. And try to get the ends up as high as you can get them. At least 5 or 6 feet usually works well for a 20-foot high pole. So performance for an inverted V offers a more directional or omnidirectional antenna as compared to the horizontal dipole. Is excellent for near vertical skywave or INVIS communications, ideal for regional contacts. You can still get long contacts with it, just like the regular dipole. Pretty simple to make. Like I said, use quality parts, good wire. And if you're making this portable, I like 26 gauge, somewhere around there, 22 gauge. If you're making it for your house, step the wire up a little bit. And sometimes even if it's going to set up and you have a lot of wind and stuff where it may get stretched, think about the steel wire. I like copper wire, but the steel wire is a little stronger. And sometimes it's pretty stealthy looking. So you might want to use that for something that's permanent. I like silicone wire for portable stuff just because it rolls up nice. Okay, number three. Number three is the fan dipole. Again, another dipole, but this one's different. Fan dipole is, if you keep it around 3 different bands, it's fairly easy to tune. But how it works is essentially a collection of several individual dipoles, each cut at different resonant frequencies. And they all feed at the same point. At a specific frequency, only the dipole cut for the frequency will present a low impedance and radiate the power, while the other off-resonant elements will have a high impedance and block the signal. So it's kind of like magic. It just works. When I first started, that was one of the first antennas I made because you can get multiple bands and not have to have a tuner, okay? They are a little more difficult to make, and we'll talk about that in a little bit. The physical appearance, the elements are spread out in a fan shape from a central feed point, which each element often running at least different angle to reduce interaction. So you will have some interaction, so tuning these is a little more difficult than just a straight single band dipole. Basically, the components are the same for making one of these yourself, and it just takes some more time. Performance-wise, it's pretty good because one other thing I wanted to say: if you only want 20 and 40. Do one this way and then do one this way. It actually can act as your guy lines for your mast, and that should be a little bit easier to tune, okay, because they're not interacting as much. But usually, I showed you a picture here someplace how they usually set like this, okay. But if you're making this for portable, you can, like I said, you put them 2 different directions. You got 4 points to stabilize your mast. Efficiency can be highly efficient, close to 100%. If built with low-loss materials and installed high above ground. Tuning requires careful tuning. You can start with longer than calculated elements and trim them to the correct length, adjusting the lower frequency elements first. So if you're doing 40, say 40, 20, and 15, do 40 first, do 20, and then do 15. Like I said, there is some interaction, so your exact lengths won't be right. Always start long. Again, just like any other dipole, easy to make. All right, moving on. The end-fed half wave. Now, the end-fed half wave is super, super popular these days because it's pretty easy to set up, usually in a sloper configuration. An end-fed half wave is a single wire radiator approximately half a wavelength of its lowest design frequency with a transformer or un at one end of the coaxial feed line connected to the transformer. The transformer steps down the high impedance at the end of the half wave antenna to 50 ohms impedance. And that's what your radio wants to see. Common transformer ratios are 49:1 and 64:1. A major advantage is it does not require a large grounding system or multiple ground radials. One short counterpoise or even a few feet of coax. I don't usually recommend it. I like to have a choke, but the coax can work also. And guys, do what you want to do. I don't care. That's often sufficient. Though DC grounding is also recommended for static protection, and that's probably more for if you're going to set this up at your house. The end-fed half wave are naturally multi-banded, operating on the intended band and its harmonics without retuning. So what that means is if it's an 80 or a 40-10, it means it's good on 40, 20, 15, and 10. And a lot of times you can, with a decent tuner, you can tune 17 and 12. I've also gotten 6 a few times too. Now, when you're tuning it, it's probably not as efficient as an antenna cut for that band, but it should work and it will get you contacts. Efficiency. Performance is generally pretty good, but the transformer losses increase significantly at higher frequencies like 15 and 10, leading to a reduced efficiency despite good SWR. So is it going to be as good as a dipole cut for 10 meters? Probably not, but it'll be close. As far as do-it-yourself, building an end-fed half-wave is a popular project because it's relatively simple, involving a wire and a transformer. It is a cost-effective alternative to buying commercial antennas which can range anywhere from $40 to $180, and sometimes even more. It's crazy what some of the companies get for a built antenna that you can do yourself. So construction, the transformer can be hand wound on a ferrite core, and the wire can be purchased off the shelf. Usually you use magnet wire, and it's a simple line. There's all kinds of diagrams on the internet if you want to do your own. And like I said before, kits are a great way. When you buy a kit, now you don't have to buy 5 of these or 100 of these or something like that. You get exactly what you need to build the antenna and build it right. And when you get done, you don't have a mess of an antenna. You have a nice looking antenna, depending on how well you wind your toroid. Number 5 is the random wire antenna. A random wire antenna is a single wire cut to a length that is not a multiple or half wavelength of any of the desired operating frequencies. So even though it's random, it's kind of a known size, and there's lists out there you guys can look up on Google and find what good sizes are. A random length is intentionally ensuring that they used on multiple bands, though exact length is not truly random but chosen to be non-resonant. It is fed at one end, typically with a 9-to-1 unbalanced to unbalanced transformer to match the high impedance down to closer to the 50 ohm coaxial cable, or what your radio wants to see as 50 ohm. Now, like any antenna we talked about before, it can be a compromise. The advantage to this antenna, especially for you guys that want to do like SOTA work, or you're in tight places for POTA work, the antenna wire can be shorter. Usually for 40 to 10, we recommend 41 feet. In our kits, we actually give you enough wire for a little bit more than that, but 41 feet is perfect. If you want to get into the 80 and stuff like that, go 71. It can be a pretty good distance antenna, DX antenna also. DIY for this antenna is pretty simple. Makes an excellent project for beginners. Construction requires minimal materials, a length of wire, 9-to-1 which can be homemade, which I encourage. It can be set up as various configurations, same as the InFed halfway. You can do it at a inverted V, or you can do it as a slope or a vertical, like I said. All right, number 6. The off-center fed dipole, sometimes called the Wyndham. It's a halfway dipole with the feed point located off-center, typically around 1/3 the length of the total length. So instead of, my head being the middle of it, it's set more like this, okay? The off-center feed point creates a resonant or near resonant antenna on multiple harmonic bands. For example, an 80 meter off-center fed dipole can work on 40, 20, 12, and 10. Performance, a lot of people love these antennas. I've messed with it a little bit. I think I was getting I don't think I choked it very well. And I was getting interference back into my amp, and it kept kicking my amp off. That was my fault though. But a lot of people really, really love these antennas, and they seem to work really well. So excellent performance. Okay, it's like any other dipole. They all work good. Minimal loss with a good quality coax and balun. Like any other dipole, it will be sensitive to surrounding objects. Like you don't want to set it right next to a building, or sometimes you just got to do what you got to do, but try to keep it away from other things. Tunings may require trimming to achieve the lowest SWR, like all the other antennas, on the desired bands, especially for the fundamental band. Now, variations, specific designs like the Carolina Wyndham add a choke balun to create a vertical radiator component which can lower the radiation angle and improve long distance performance. Now we get into verticals. Now, verticals can be great antennas for DX because they have a low takeoff. A quarter wave vertical is essentially half of the dipole antenna with one vertical radiator element and the other half provided on the ground plane. So now you do need ground radios for this to make it work good. The more the better. For portable use, you can use less because you're only going to use it for a few hours, right? But if you're doing this at home, you might want to put more. It says minimum of 20. So the radios act as a reflective mirror image of the vertical element, and a good ground system is crucial for it to function effectively. Placement of the radios can be installed horizontally, angled, or angled downwards. The radiation pattern is omnidirectional, means that it transmits in all directions. It also picks up other signals from all directions, which can make them noisy at times. Takeoff angle is lower takeoff angle, which means more distance because now it's bouncing less times. If you guys remember, the more it bounces, the more power you lose, right? A common drawback is sometimes noise. Sometimes the noise, though, what I've found in the past, I've had verticals and horizontals all up like a dipole and a vertical up at the same time. And sometimes the noise is different and sometimes it's better than the horizontal. So it's good to have both if you can get them up there. The inverted L. An inverted L is 1/4 wavelength antenna where the vertical part is bent into a horizontal section at the top. It combines vertical and horizontal polarization components, unlike a pure vertical or dipole. It can be a 1/4 wavelength total, resonant or longer. Non-resonant wire with a matching transformer can be used also. So if you can't get it really long and you want to tune other bands, just get it as long as you can get it and put like a 9-to-1 or something at the bottom. Has a low angle of radiation like other verticals, so it's good for DX communications there. But the horizontal section is a higher angle, so you're kind of getting a little bit of both here. You're getting the vertical and you're getting the dipole. Okay, the radiation pattern is slightly asymmetrical, a bit more gain in the direction opposite the horizontal wire. The do-it-yourself factor. The antenna is easy to build, basic components, just like any other of these wire antennas. You need wire, a radiator, a support. The biggest problem with these are the support. Now, a lot of times people will use a mast and then take it to a tree that's higher. Basically, you tune this antenna like you would any other antenna, like a dipole, by cutting it or linking it longer. Hopefully, you're just cutting it. Okay, number 9. The Rybakoff vertical. The Rybakoff antenna is a vertical, sometimes called the Rybakoff 806, typically consists of a radiator that is approximately 25 feet long or 7.6 to 8 meters, often supported by a non-conductive mast like a fiberglass fishing pole. Now, note that I said a non-conductive mast. Now, this antenna uses a 4-to-1 un at the feed point. Usually the feed point is set low to the ground also with ground radios. You need to have ground system for this. At Coffee and Hammerheads, we came up with the Poseidon. The Poseidon is our version of a Rybakoff. The difference is we use more radios. We use 4 17-foot radios to give a little bit more push. And we also use a different toroid than most people. Most people told us it wouldn't work, but it does. But we use a different toroid that will allow your internal tuner of your radio to tune 40 to 6. You need a counterpoise or ground plane. The ground system is necessary. This can range from a single counterpoise wire or multiple radios for better performance. We chose multiple for better performance. It is a compromise. Now, you will need a tuner for this. The Rybakoff antenna is a popular choice due to its versatility and practical performance, but it has its limitations. It exhibits a low angle of radiation, which is favorable working DX stations. It's a compromise antenna, and efficiency can vary by band. It performs surprisingly well from 40 to 10, but less efficient on 80 due to its short electrical length, where significant power is lost into the soil resistance and matching unit. We recommend 40 to 10. If you need to make that contact, you need one more contact on your POTA, and it's getting late, and 80 is the open band, use it. Okay, portability for this antenna, it's pretty lightweight design. It uses a fishing pole support, so a 10-meter pole works great. Fiberglass, remember. Very friendly antenna to build yourself. Pretty easy. A 4-to-1 is like the easiest antenna balun to make or un. Really, really simple. Just don't cross your wires. The number 10 is the doublet. I'm going to be doing a video pretty soon on a really cool doublet, and I think that's something we're going to offer pretty soon from Coffee and Hammerheads once we get our store back up. The structure of a doublet is a balanced antenna, essentially a dipole with a balanced feed line such as 300 or 450 ohm ladder line or open wire feed. Now you can make your own wire feed also for these, but it's pretty easy to buy it. And a famous antenna out there is the speaker wire antenna, basically a doublet. Basically, they split the wire at the top, bring the two down. They don't split it where it comes down for the feed line. Basically, a doublet, guys. And they work really well. It's designed to operate on multiple bands without requiring a physical retuning by using a balanced feed line and becomes part of the antenna system. So what they're saying there is you don't have to shorten the ends or lengthen the ends. It's you just tune it, okay? The balance feeder's low loss is crucial, especially when the antenna is not at perfect impedance match on a given band. The open wire is or ladder line is more efficient than coax, is what they're saying. The primary advantage of this is its ability to be used on a wide range of frequency without recutting or major adjustments, as the feed line can handle the high SWR. Efficiency. It is highly efficient due to its low loss balanced feed line. When used with a quality antenna tuner and a choke balun at the shack, usually a 1-to-1 or a 4-to-1, they're going more towards 1-to-1s now, but both work. It minimizes the common mode noise pickup. Now, my antenna is pretty dang quiet, I have to tell you guys. I run a pretty nice balun and also use a choke. The antenna can be a flat top, sloper, bent, configured as an inverted V, or installed in other ways to fit your surroundings. Now, mine's a sloper. It's at 40 feet at one end and 30 feet at the other. And I have to say, guys, it works really well. It requires an antenna tuning unit, ATU, to match the transmitter to the antenna system, which is necessary in efficient operation. Now, with this antenna, you don't want to use a lot of coax. That defeats the purpose. So what I do here is I come into the house with my 300 ohm. I use 300 ohm. I bought a kit. And from there, I go to my balun, and then I have like a short, it's like 6-foot piece or 4-foot piece of coax. So you want to minimize your coax. If you put more than 10 feet, you're pretty much defeating the purpose of this antenna. Now we're getting into wire antennas that have gain. Now there's a few of these. There's even another one that I don't have down here, but it's a little more difficult to build. Now the first one is the hex beam. The hex beam is really nice. It looks like an upside down umbrella. The advantage to this setup is you can get multiple bands pretty easy, as opposed to the next one we're going to talk about. It's a little harder. A hex beam consists of 2 wire elements, a driver and a reflector for each band, arranged in an unconventional shape of a hexagonal frame to achieve shorter turn radius than a full-size Yagi. So instead of having something that sinks way, way, way out like this, it's more compact. Now it does take away a little bit of the efficiency. Like we said, everything's a compromise. Multi-band. It can cover bands such as 20 through 6. You can do more than that if you could figure out a way to make something bigger to do 40. Some of the kits antenna makers out there had a 40 kit, but it was basically a rotatable dipole, not 2 elements, okay? If you can make it big enough, you can do it, but it gets kind of hard. 20 is hard enough. You use a balanced feeder, a non-conductive center post with the driver's element halves connected to the center post at the feed line point of each band. So basically it has a 20 and goes 17, 15. So each band is a different level on the post, okay? Going down to 6. Performance. Okay, here we go. This is what this antenna and the next antenna gets you. 3 dBd of gain, or 5 to 6 dBi of gain. Okay, that's a lot. Now the other big thing in this is front to back ratio, 13 to 22 dB of front to back. Okay, that means anything behind you, it's shutting off. Now you can still hear people from there, but they won't be as strong as if you turned it towards them. Okay, that's good for you guys in the middle of the states. Usually I'm just pointing northeast from California. I go with that. But if you're in the middle of the country and you only want to get west coast or east coast, or go west or east, and you want to concentrate on that area, this can really help you out. Pretty broad banded also for an antenna. It performs well across the entire bands without needing the retuning. Weight and size is a factor. Most of it's a pretty light antenna usually. It doesn't have to be really, really high to work also. 30 feet's 25 to 30 feet usually, okay? All right, do it yourself factor. Now this antenna, while it's the hardest part of this antenna is building the hub for it. And then the next part that's hard is tuning all the different bands. So it does take some time, not impossible to do. And most people can do this. It's just like doing a dipole, only you're doing 2 parts. Okay, you have your driven and your reflector. So you have to adjust both. I've also noticed that the measurements you get for the separation sometimes, if you're having a hard time, play with that a little bit. Usually they say that's the part you don't mess with, but I found out that it works sometimes, and it does help to get your SWR and where you want it. All right, number 12, and this is my favorite antenna. If I want some gain on a POTA or SOTA, the Moxon. The reason I like the Moxon is usually it's harder to do multiple bands than the hex beam, but it can be done, but it takes a little more work. But what I like about it, for me, when I do a POTA or a SOTA, 20 meters is like my buddy, I didn't remember saying it, but I said this one time, 20 is money. It's meaning that 20 meters is my best band for, I'm not surrounded by states. Like the guys in the middle of the states, 40 works great because it's less distance. So when you're surrounded by people, I have water. I mean, I've got ocean, Hawaii, and then Australia and New Zealand are the closest, and then in Japan and stuff like that. So the Moxon is two element Yagi with the ends bent in. It looks like a big rectangle. Okay, that could be like that. All right, I'll show you pictures of it. It's usually set up in horizontal, but can also be set up in a vertical, which is great for the beach. If you guys are on the beach and you set this thing up vertical, and you know, I've been preaching this Moxon for a long time, and now people are starting to notice that they're great antennas and they're super easy to build. Less parts. You only have 4 spreaders versus the 6 on a hex beam. Everybody, we all know kind of that verticals are supposed to work really good at the ocean, on the beach and stuff. So this is no different. So the overall size of this is about 30% smaller than a full-size dipole or Yagi. It consists of a driven element and a reflector, just like the hex beam does, which are typically made of wire in a rectangular design. I've also seen these made square. I can't find it, but I found a guy that makes them square. I don't think that makes a difference. I mean, if you get your angles off a little bit, it doesn't make a difference, okay? It's the length of each wire that makes the difference. Feed point is usually around 50 ohms, which is what your radio wants to see, right? And so you don't need any kind of a matching network. A balun is good. Gain, about the same as a hex beam, about 5.5, 5 to 6 dBi, so 3 dBd, okay? Which is good. The front to back is another thing. This actually has a little better front to back, about 25 dB front to back, which again makes it good for cutting off those signals in the back that you don't want to hear. It offers a wider forward beam width compared to a standard Yagi, making it a good option. All right, the do-it-yourself, like I said earlier, the do-it-yourself on this is a little bit easier than a hex beam. You're only dealing with one wire usually. Very cost-effective. Parts. If you guys look at my videos, I did a 10-meter one. I used carbon fiber, which I know I've already talked bad about carbon fiber, but it doesn't seem to affect the elements are up and away from the carbon fiber. But the thing weighs like less than a pound, and it's for 10 meters. The hardest part of this, again, is tuning. There's all kinds of calculators out there. They're always wrong, okay? So I found. They're usually a little long, which is good. Then you can just cut things down. And like I said, sometimes mess with that distance between the reflector and the driven. Sometimes if you're having a hard time, just resort to that. The hardest part is basically the frame for it, guys. A pretty good project for 3D printing. I did a video like the 10-meter one I did. That's 3D printing. So I hope this was a good video for you guys, and I hope you'll learn something. I always learn something preparing for these. Every time I do one of these videos like this, I learn something. And that's what ham radio is all about, is learning and building. Building your own antenna can save you a lot of money over buying a built antenna. Kits can save you a lot of time looking for all the parts. So there's your choices, or you can just build it out of I've built stuff out of parts laying around my house. PVC is a great thing to use for making the center parts. Look up my 20-meter dipole build on YouTube. It's super simple. I think I even show you how to tune it. So I'm Chuck, KK6USY. This is Ham Radio Ventures. Thank you for spending your time with me. 73 all, and hope to catch you guys on your own wire antenna that you built yourself.